What's up, y'all? We're on section 5-6, the fundamental theorem of algebra. Let me throw some papers around here, and we can get started. So section 5-6. Section 5-6. Fundamental theorem of algebra. Section 5-6. Fundamental theorem of algebra. So the fundamental theorem of algebra. Fundamental means it is very important. A theorem is an idea that we can prove. And algebra is where you're sitting. Okay? So the fundamental, the very important idea about the class you're in. Well, this sounds important. So let's see what that is. The fundamental theorem of algebra says a polynomial, of degree n. So whatever its degree in, if it has an x cubed in it somewhere, it's the third degree. Well, it has, a polynomial of degree n has n zeros. What are some other words we have for zeros? We could say solutions. We could say roots. Has n zeros. Okay, and this might be something that you have guessed is true. When we had started to have x squareds and quadratics, we sometimes had two solutions, and then 3 or 4, depending on those higher degrees. So let's look at an example, just one problem here. I'm going to give you something. We're going to start off with the big one. So let's start with x to the 5th minus x to the 4th minus 3x cubed plus 3x squared minus 4x plus 4 equals 0. So this is a polynomial equation. There's a lot to it, right? A 5th degree. So what that means is that we're going to have 5 solutions. So I'm going to graph this, and we're going to see 5 solutions. How exciting. I can't wait. X to the 4th minus 3x cubed plus 3x squared minus 4x plus 4. Okay, 5, 4, 3, 2. Okay, I think that looks good. Sometimes I leave off an x, but I think that's good. And let's see. I'll zoom standard. I'm not sure what my zoom is. I'll zoom standard. We should see 5 solutions. 1, 2, 3. Oh, crap. Oh, yeah. So solutions has n solutions. Well, we have 3 solutions here, and we're going to have 2 more solutions that are complex or imaginary. Okay, they're not going to be on the graph, and we can find those. We're going to use the quadratic formula when we get to that point, but we're not there yet. We're going to start with these 3 that I know. If you think about the rational root theorem, it has to be 4. Well, let's do this real quick. Let me actually write it down. Okay, the rational root theorem, the RRR, I guess. R3. Whoops. Okay, the RRR, the rational root theorem, was got to be 4, 2, or 1 over just 1 there. That's great. So the only possible rational roots are going to be 4, 2, or 1, or negative 4, 2, or 1. And that's what we see on our graph. We see the solutions negative 2, 1, and 2. So we have those 3 solutions. So from the graph, we have negative 2, 1, and 2. And we could burn a calorie or 2 and make sure that those are right. So we could trace and hit negative 2 and it comes out to 0. Yay! 1 hit enter and it comes out to 0. Yay! 2 hit enter and it comes out to 0. Yay! You have to give the same yay to all the zeros, or you could incite jealousy between them. Okay? So from our graph, we have those, and then we're going to find the complex solutions in a minute. But first, I need to do this. We're going to use synthetic division, and we're going to put these 3 numbers in the box, and then that's going to give us an equation that we can use to find those complex roots. So just come on this journey with me for a moment. Let's start with the easiest one. Let's start with the 1. We're going to use synthetic division, so remember the little box there. I guess I should have written the problem down. Find all roots. Find all zeros. You know, I just look up there and it bugs me. So that was the problem. Those were our instructions. You don't just look at a polynomial and start to do stuff, right? You need instructions. So those are the instructions. So I'm going to put this 1 in the box. 1's the easiest one. So I'll start with the easiest one. And then we'll write down the coefficients from this equation. So 1, -1. So yeah, 1, -1, -3, +3, -4, and +4. Okay, and remember, you drop the number down and then multiply. Drop it and multiply. So drop the 1 down, and then multiply. 1 times 1 is 1. Okay, combine these two together. -1 and 1 give you 0. And then multiply by the 1 again. 1 times 0 is 0. Okay, -3 plus 0 is -3. 1 times -3 is -3. So we're going to see this pattern where these are going to cancel out a few times. I think that'll be okay. 1 times 0 is 0. Add those up. 1 times -4 is -4. And that gives us 0 there. And I don't like to write the 0 because I might use it next time. That's just the remainder. That goes away. That's gone. So I don't need to worry about that. Okay, so that is good. Now, I have a couple other zeros. Let's do the 2 next. And just put it right there. There it goes. We're going to do the 2 next. Okay, so bring down the 1. 2 times 1 is 2. 0 plus 2 is 2. 2 times 2 is 4. -3 and 4 give me 1. 2 times 1 is 2. 0 and 2. 0 plus 2 give me 2. 2 times 2 is 4. Okay, so I've done the 1 and the 2. We need the -2 now. -2. So bring down the 1. -2 times 1 is -2. That'll be 0. Okay, 0. 1. -2 times 1 is -2. Great. Okay, now if you don't remember, when we're done with the synthetic division, what's left, this is just a number. That's the x, and that's the x squared. So this is going to be 1x squared plus 0x plus 1. And it's still, we're going to copy this up here. It still equals 0. Okay, now in this case, because the 0 is in front of the x, it's going to go away. So let me simplify this for a second, and then we'll think about how we're going to solve this. So I get x squared plus 1 equals 0. Okay, x squared plus 1 equals 0. Well, there's no x in the middle, so I don't need to use the quadratic formula. We could use it with 0 for b. You know, use 1 for a, 0 for b, 1 for c. But we don't need to do that. Just solve directly for x. So move the 1 over and take the square root. Remember, when you take the square root, do the plus or minus. Okay, because when you square a number to get that -1, it could have been positive or negative out here. We don't know, so we're going to include both. So x equals plus or minus. Well, the square root of -1, we don't leave it like that. We write I. X equals plus or minus I. Okay, so this is actually our last 2 solutions, right? Let's go back to the top of the page. Okay, we're supposed to have 5 solutions. This is a 5th degree equation. We're supposed to have 5 solutions. We got 3 solutions, -2, 1, and 2. So we need 2 more to get the 5. Well, they're right here. Positive I is a solution, and negative I is a solution. So let me write that out. Solutions, or zeros, or roots. And yes, I spell my zeros incorrectly. I do it because I want to. I think it's fun. I think it's fun. That's my idea of fun. So, -2, 1, 2, I, negative I. And you could have written that as plus or minus I, but I'm really trying to drive this point home, that we have 5 solutions, because it has to match the degree. And these are your notes, the fundamental theorem of algebra. Try to find those 5 solutions. Unless you have a quadratic, you're going to need some help, either from the graph or something like that. But once you have a quadratic, this could have been anything right here. And you could just use the quadratic formula to finish it off, or you could factor, or you could just solve directly for x if there's no value for b. Fundamental theorem of algebra. It's awesome, huh? Tell your friends.